Hey, this is Tiger, welcome to my stream. And again, we are doing simulation stuff here. Everything that I am talking about is for playing a computer game, a simulator, and nothing else. Dobry den to the Czech Republic. Hey, AJ. Yeah, let's go into the game. Nice to see you, CD Radar. Today we're talking about cap signaling in ETCS, and well, that gave me quite a headache to figure out how that can be presented in a stream of that kind here. So let's turn on the DLC marker. We have to play Luzern Sursee because, yeah, that is finally what we want to see, and the only DLC that supports it. I also turn on the corresponding service again, so I've been playing Southeastern High Speed to relax, where is Luzern Sursee timetable mode. At least picking the train is easy, since there is only the Stadler RABe. And I wanted to play 11:14, is that what? Yeah, 11:14 Luzern to Sursee. Let's just jump in and yeah, let's see what Rivet made out of the cap signaling in ETCS. I watched a lot of videos that are on YouTube that show our ETCS cap signaling in action, and you can find all versions and variants. Well, first we have to turn on the train, obviously turn on the main switch, put the reverser to forward, open the doors, and then turn on our computer here by pressing the 0 key and then the E key. Activate the level 1 passenger lights I want to have, and since we're going to Sursee, I think we're running a regular S-Bahn service. Lock the doors. We're already a bit late, there is not a lot of setup time in this DLC. Reverser to forward. What is the problem? Did I already move my marker? What did I do with to my poor train? Why are we not moving? I did not release the brakes. Okay. That explains a lot. Let's release the brakes first. That makes departure a lot easier. I was so focused on my ETCS display. Well, yeah. At the moment, you can see that we just started. This is why we have this icon here, the crossed out eye, meaning that we are in staff responsible mode. We are restricted to 40. We are not allowed to go faster, but we are not controlled at the moment. Although we are on level 1, as you can see here, it is up to us to stay below the 40. To not run any red signals. Good thing the signals are green. And as soon as we hit the first balise, you can see that this icon here turns from a crossed out eye to a not crossed out eye, and then we are in full supervision mode, and at the same time you can see a gray bar on our speed clock popping out of nowhere, indicating how fast we can go. You can see here is the point where we switch to 80 track speed. Here are the balises, and zack, already the bar is here, the eye is no longer crossed out, and our speedometer allows us to accelerate to 80. But if we do that and accelerate to 80, you can totally see we're just lucky because I explained so much. What I just wanted to demonstrate Rivet's version of this cab signaling here does not take into account that the train has to pass the signal before it can actually accelerate to the 80. The ETCS limit that is shown on the speed clock here just jumps to the new value as soon as we hit the balises, what has been criticized on the forums. And yeah, for a reason, because usually ETCS should take the length of the train that is actually stated here on the display into account, and should show you the new speed target not before it is actually valid because you have passed the speed changing point. You should get the data that you need from the balise, and the rest your train should know. So here speed changing to 85, and again plop, the gray bar that shows us how fast we can go just jumps to the 85, even though the train has not run its full length. So that is the first thing in the cab signaling here. The train shows us how fast we can go, and at the same time, if it tells us that we can go any speed, it tells us that we have a clearance to go on that track, a movement authority that we are getting from the balises. And it will tell us if we have to slow down, and it will tell us if the speed limit changes. When the speed limit increases, you have already seen it. But now we're running up to a yellow signal. As soon as we hit the balise, the cab signaling will react, we get a sound, and we get a yellow curve, and this yellow curve tells us to slow down. As soon as we are in the braking curve, the yellow bar shrinks and we have to go alongside. At the same time, on the left side you might have seen that there is a bar indicating the distance to the point where we actually have to stop. We passed the yellow signal, so the next one is most probably red. And so the train is flagging us down. You have just seen that we did not follow the speed curve that was calculated by the train, and we get an overspeed warning. What is not totally correct, because we are in a release speed here. We will talk about this in the presentation. Here we should not get an overspeed warning. The signal turned to yellow in the meantime. The thing is, since we are getting our movement authorities from the balises, we have to sneak past the signal that used to be red to get the new movement authority from the balises, from the next balise that is behind the signal. But we will talk about this when we are in the presentation. For the moment, just look at the yellow curve. Now we have again a yellow curve because we passed another yellow signal with a new red signal in front of us, so we will have the same procedure again. A shrinking yellow curve indicating our calculated brake curve, and at 40, you can see 40 is our release speed. We will be released from the supervision insofar as that we do not get any overspeed warnings and emergency brakes anymore, but the train still shows us how far we can go until the stopping point. Signal has changed to yellow. Thing is, since we are getting all the data that we have from the balises, the train does not know the signal status after passing the balise. We don't have any Euroloops where we could get this continuously. Only the balises. Now we actually have quite a long wait at the station here in Emmenbrücke. Maybe we use the time virtually to already start with the presentation and to put into its place what we have already seen happening on our ETCS DMI, driver machine interface, on our display in the train. You remember that from last week. If you have not watched the stream or the video from last week, you can find it in my YouTube channel. It is the ETCS in a nutshell. What does CD Radar? A friend of mine who is a train driver says that ETCS is a reduction in safety because it forces you to watch the screen more than the track. That is a viable opinion, actually. Obviously the driver is still required to watch the track, but since there is so much happening on the screen, even more that is simulated, I have heard that, yeah, I have heard that in videos the train drivers are saying they are not actually doing anything else but watching the screen, or others say they are not watching the screen anymore, they are just listening to the sounds that the system makes when watching the track. So that works, or seems to work as well. Yeah. What did I want to talk about? This is the summary that we had in the stream last time. You can find it on my channel, ETCS in a nutshell, and see all the concept and the players in ETCS, its different levels, and the baselines for the operating modes and so on. What I wanted to show here is the matrix. We were talking about in what modes we are relying on the trackside signaling alone, in what modes we are relying on trackside signaling and Class B systems, our old national train control system like PZB or Integra Signum or KWB or AWS TPWS, and in what levels and situations, modes of operations, we are actually using the cap signaling that we have had a first glance at on our journey from Luzern to Emmenbrücke. There are the three levels of ETCS. Level 0 does not get any data from the track. It can only monitor the maximum speed that is programmed into the train. On ETCS level 1, what we have been using in this DLC, we're getting our data from Balises and the loops. All that is in a more depth explained in the last week's video. And ETCS level 2 was the level where we get everything by radio, our movement authority and all the data that we need for the cap signaling. In level 0 there was the level STM, or the national systems in the baseline 3, and no cap signaling on level 0. On ETCS level 1 we had the limited supervision as the mode that is usually employed on that level where we used the national systems, and there is a full supervision mode 2. In ETCS level 2 the limited supervision mode exists, but it is not used, but this is where in real life train carriers are using the full supervision. We had the modes where we are using only trackside signaling without any monitoring. For ETCS level 0 that was the unfitted mode, and for level 1 and 2 we have as a backup system the staff responsible. We saw that in the game until we reached the first balise, or the on-site mode, where we are restricted to a very slow speed and can rely on track signaling alone. In the game we had, in the first stream about ETCS in Luzern Sursee, the level STM, where we are using the legacy system, the Euroloops alone for train control. That was implemented in last week's stream. We were running the train on level 0 in the unfitted mode of operation, relying on trackside signaling. You remember, with this specific mode that Rivet programmed for that, and today we are looking at this that is implemented by Rivet in the Luzern Sursee DLC, full supervision cap signaling, and on level 1 what the ETCS rules totally allow, but what is regularly not used in real life, to my knowledge, because on level 1 railroad carriers are using limited supervision. and the staff responsible is also implemented. We had this already when we started at Luzern. CD radar says, but from my point of view as a subway train driver, where we have line safety systems, and thus I am used to looking at everything at once. Yeah, that is the best that you can do. And I think as a subway train driver, everything happens so fast, and well, when you're in a tunnel, I don't know, how much do you actually see when you're in a tunnel and driving your subway train in a tunnel? You can't actually get a lot of information from the track there. At least in my imagination. Yeah. Back to our presentation. So this is what we are doing today. Full supervision. Full supervision on ETCS level 1 cab signaling implemented by Rivet Games. Level 1 was the level where we get our data from the balises. The idea is we are not using the radio connection as a radio block center to get the signaling data continuously into the train, but we are using the balises for a non-continuous connection between signal control and the driver. We are not using in full supervision mode, even on level 1, the trackside signals anymore, but we still have a driver, and we are sending the information to the driver through the balises. So the train has its balise transmission module, and it reads the fixed data balises, the infill balises, and the Euroloops for a continuous update, at least for a certain length of track, especially in front of a signal. We did not have those Euroloops in our approach on our signals. This is why we always got end of movement authority and the release speed, and then we had to sneak past the signal, and at the next balise we got the new movement authority. With a Euroloop, this would have been smoother, but it is not in our track, it is not in our DLC. What we have on the radio is in case of an emergency, the driver can actually talk to the signaler. And what we see on our display, it is the one with the squares indicating that we are not getting a continuous feed of information in our train, but only a non-continuous, as I just said. In the beginning we had the staff responsible mode, where we did not have any data yet from any balise, so we were actually forced to rely on our driver, and thus restricted to a speed of 40 tops. And as soon as we hit the first balise, the staff responsible mode switched to full supervision, and then the cab signaling kicked in. And what does the cab signaling do now? It shows you how fast you can go and if you can go at all. And it warns you about incoming speed reductions, and as we have seen, it helps the driver by displaying a speed curve, a braking curve, in the approach to the point where the train needs to be at a slower speed or at a stop actually. So let's just look at an example track. This is the track, and let's say we can go 80 in the beginning, and then there is a point where we can speed up to 140, and then we have to reduce our speed to 100. You know, this is the Swiss speed signaling. Here is the advanced warning about the reduction, and here is the sign that says here commands is actually the speed reduction. So if we paint or draw a diagram on this, this is the 0 line. So we have a line for the 80, this is where we start with. Then we have a 140 for here, a 100 line for here, and then since the balise is at this point, not at the beginning, we have this 40 line for the staff responsible mode at first, because at the very beginning the line limit might be 80, but we do not have a movement authority from the balise, so we are restricted to 40. So our train has to comply with this speed line here. This is what we would see on our pause screen. until we hit the balise 40, because staff responsible, then we can actually go to the line speed of 80. At this point we can go to the line speed of 140. At this point we need to be down to 100, and since the train cannot just accelerate and stop without any delay, we would have a speed curve, or we would aiming for a speed curve that looks like this. At 40, then we accelerate to the 80, then we have actually to run the full length of the train until we can accelerate to the 140, then we accelerate to the 140, and then we have to slow down until we hug to the new limit of 100. And this is what ETCS is controlling us to. So the blue lines are the controlling lines. I drew two of them. We will see that on the next slide, why not more than or not less, but there are different steps of intervention that the system provides. So there are actually even more than those two lines required, but those two lines are the most important ones. So we will be controlled to that, and since ETCS knows how long our train is, it can calculate and actually control us beyond the speed changing point to the old limit, and then other way around, then the limit increases and it controls us to the new ceiling speed. And then, since the system is intelligent, it can calculate a brake curve that we must not violate, and then at a certain margin of error in front of the next speed changing point, we are supposed to be down to the new limit, and then we will be controlled to the new ceiling speed. So this is about the idea of the speed control of the that happens here, and this is the base or the basis for our recap signaling. This is the length of train. This is where we have this offset between the speed change and the change in the curve. On our display we will see for this distance here this icon for the staff responsible mode of operation, and on the speed clock we will see nothing special. So I hope you can see what I want to say with my iconized speed clocks here. It took me quite some time to make this on PowerPoint, so I hope this works with what I achieved here. So the speed clock is quite normal as long as we are in staff responsible mode. We don't get any indication that we are limited to 40. There are other modes. The on-site mode, for example, you get a dot here that indicates where the limit for you is. On the staff responsible, you don't get any indication. As soon as we pass this balise here and the train is picking up its data, it switches to full supervision mode, and then we can see this gray bar that we have seen already in the game, indicating our movement authority and our speed limit. So as long as we have a gray bar, we know we are allowed to go on, and we know how fast we can go. The needle in the middle, the hand on the speed clock, it will be in light gray in those statuses. As soon as we hit this point here, the 140, and the limit increases, then we have to travel the full length of the train, and then the speed limit just increases on our speed clock. Then it just jumps to the new value. So there will be no alarm, there will be no increasing, no growing of this. It will be just in an instant, it will just jump to the new one, and then you don't need any roadrunner system or whatever. You know your train has traveled its full length, and then you can accelerate to the new limit. This does, as we have seen, not work in the game, because the game already switches at this point, or even before. When the train is picking up the balise, it shows this new indication on the speed clock. This should not be like this. And then how does it proceed as soon as we, well, this is sometime here in the German directive. It gives you a number of about 10 seconds before you hit the brake curve here, but this is an about value. The descriptions of the systems between the Swiss Fahrdienstvorschriften that I have cited here, or the German directive that I have cited on the next slide, they are not always on the same point. They differ a bit. This might be because of different implementations, different versions, but it does not make it easier. But this is, or might be, the reason why, if you're watching videos about ETCS in action on YouTube, it might look different from what you see here, from what you see in the game, or from what you see on other videos, because different versions can have slightly different implementations in the cab signaling system. But what is supposed to happen 10 seconds before you hit the brake curve? You should get this. Part of your gray bar should turn white. Also the hand should turn white, and indicating you how much you are supposed to reduce your speed at the next speed changing point. At the same time, on the left side next to the speed clock, you get a bar indicating the distance. There will also be some numerals on top of the bar in real life, not so in the game, not so here on my iconized speed clock, telling you the exact distance in meters until the new limit. And this is supposed to warn the driver about the incoming reduction, so that he can take actions and prepare his braking. At the same time, you will get an so-called Aufmerksamton, an attention alarm that is like beep beep, two short unobtrusive sounds, beep beep, and yeah, ETCS tells you there is something incoming. In 10 seconds you have all the time in the world to prepare for it. The problem is, if you have a track with a lot of speed changes, with a very dynamic speed profile, you will never get out of this phase, because you're always 10 seconds in front of the next speed changing point. And this is why this white bar, the advanced brake warning, has been deleted from the latest version of the system requirement specifications, the 3.6 version. The 3.4 version still has it, the 3.6 version does not have it any longer. At least this is what you can read in the sources. In the game you will see that it is still in there, and we have found this last week already. Since the game is using a level STM, we know that it is not running on the baseline 3 at all, but on the baseline 2. So we are using the SRS 2.3 in the game, not the SRS 3.x. So this explains why we have this white thing in the game actually represented. Then, if you are approaching to the speed changing point even more, about 4 seconds before you hit the brake curve, the white thingy and the needle, the hand in the middle, should turn yellow. The bar is shrinking since you are getting closer to the point where the new limit is, and in this state here the white bar should turn yellow. Again, telling you, right end of the yellow bar, this is your actual current speed limit, and the left end of the yellow bar indicating where you have to drop your speed to. Again, you will hear an Aufmerksamkeitston, an attention sound, beep beep, and then you know, okay, now the brake curve is imminent, and I will have to put my hand on the brake lever and start reducing the speed. And then when you are getting closer, at this point you hit actually the brake curve, and then this yellow bar starts to shrink, just as we have seen that in the game already. So you hit the brake curve here, and I have tried to show this with 3 different versions of this icon, where the yellow icon is shrinking, and at the same time this bar is obviously shrinking, so that we are getting closer to the point where we need to be at the new level. In the game, we will see that later when we are running back from Sursee to Luzern, is what you can see is that the white bar is already is actually shrinking already. From what you can read in the Schweizerische Fahrdienstvorschriften and in the German directive, at least, the white bar should not shrink at all. It should only the yellow bar should shrink. But I have to admit, I have seen an ETCS real-life video, I think from Bulgaria, where you could see the white bar shrinking. So there are obviously implementations and versions where already the white bar can shrink in approach to this point here. Alone, judging from the Fahrdienstvorschriften and the directives, it should only be the yellow thingy that shrinks. And then, as soon as the train gets to this point and gets the new speed changing point at the point here, then the yellow thingy vanishes and you should be below that new ceiling speed. And then you are again, like in the beginning, you are back on your gray bar indicating your movement authority and your new ceiling speed. So that is the increase in speed limit, reduction in speed limit procedure. The white thing as an advanced warning, but only until SRS 3.4, and then the yellow thingy that shrinks as an representation of the brake curve that is suggested by the system for you to adhere to and not to violate. And at the same time you get this bar, what you more or less know from LZB, indicating the distance to the speed changing point. What happens if you do not adhere to that? If you are violating your ceiling speed, or if you are not braking hard enough to stay under the brake curve. For the ceiling speed, we have a thing that is called ceiling speed monitoring, CSM, in the ETCS descriptions, and I have given you here not only the Schweizerische Fahrdienstvorschriften but also the German directive, and where you can read about the cap signaling in ETCS, and I have given you the point where you can find it in the system requirements in the actual SRS 3.6.0, valid since 13 May 2016, and it is a very long and complicated document. You find it in section 3.13.9, all those speeds that are monitored by the system. If you want to read it up. We have a limit in the ceiling speed. That is a static limit. And then the system controls you to it. Typically there is a warning speed that is some clicks above the speed limit. In the German directive you find 4 to 5 kilometers above, but this might actually be something that can be put to different values in national systems. And then you have a speed Eingriff intervention where the system will react to your speeding. Actually there will be typically excuse me, there will be a third line for another intervention speed. We will get to that as soon as we see what the train is doing if you violate the ceiling speed. But I did not put it on the slide here to make it a bit less confusing. So just let's assume this is your actual speed. You are accelerating and you're not stopping to accelerate because you're going to hit the limit. In the beginning everything looks okay. You have your movement authority and you have the representation of your limit on your speed clock. As soon as you go beyond the limit, but stay below the warning speed, according to the directives, nothing should happen at this point. You just see the hand of your speedometer beyond that point here. In some other implementations, at this point, the needle, the hand turns yellow, just like in a braking curve, or already orange. I have seen that in videos. Might be a thing of how you set up your system. At any rate, if you get beyond the warning speed, if you accelerate beyond the warning speed, this happens. You still see your gray bar that represents your current speed limit, and then you see an orange bar telling you that you are actually speeding, that you are beyond your limit, and not only beyond the limit but already beyond the warning limit. And you see on the left end of this orange bar how much you have to slow down to be on solid grounds again. And on the right end of your orange bar you can see the intervention speed, this one, the V, Eingriff, the intervention speed. So if you can see how far you can still accelerate until you will get a penalty brake, because this is obviously what happens next. Alongside with the orange indication, you will get a new sound. It is not the unobtrusive beep beep from the attention sound, but now you will get a warning sound that sounds like dee-dirt, dee-dirt, or something like this, twice and repeatedly. Sometimes. So the train will tell you you are actually speeding, you have to slow down. If you're still not reacting to what the train is doing and you violate the intervention speed, then the train will react with a penalty brake, and at the same time it will show you on the speed clock in red that you are actually beyond the intervention speed. So the hand will turn red and you will see a red bar telling you how far you are beyond the actual limit. So in this, you can't really see it on my representation here totally, but in this case the right end of the red bar will be at the point where your hand is pointing, and the left end of the bar will indicate how fast or how much you have to decelerate to be back in legality. And this is not all that is happening. You will get a third sound, and this is the actual alarm that goes like dee-der, 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 all the time until you are below that intervention speed or back into your limit, and at the same time the train will apply a penalty brake. And at the first point it will be a service brake intervention, so this is not like popping the brake pipe and draining it completely, but it will apply the brakes in a regular fashion. That is typically, at least in Germany and I think in Switzerland as well, 3.5 bar. Should be a point, not a colon, but you know what I am talking about. 3.5 bar. This is the maximum of a regular brake application, and then the train should slow down. If the train still does not slow down at this point, if the 3.5 bar service brake intervention is not enough and the speed still climbs and you hit the next line that I have not represented here, that is the emergency brake intervention speed, and then the train will actually drain the brake pipe and give everything that there is to slow down. So this is the actual hard penalty brake with the empty brake pipe. And then at the same time, as soon as the train is applying any penalty brake, it will light up this indicator here so that you can see that the system actually intervened with your driving and is slowing the train down. So the speed should drop as soon as the speed is below the limit again. Then the application should be released. So the train should say, okay, now we're back on solid terms, I release my brake application, hand back the control to the driver, and the driver can go on. So there is actually no recovery process necessary. Obviously releasing the service brake intervention will work faster and better than releasing the emergency brake intervention, and typically the service brake intervention should be enough to get the train below the speed again. In the game, I think it always reacts with a penalty brake, with draining the brake pipe, but we will see. We can give that a try later in the game, but this is what actually is supposed to happen here. If you are at this moment in a section of track where you are approaching a speed changing point, then your speed clock can look like this. You can have 3 different colored bars: the new limit, the actual limit with the advanced brake warning in white, and the part where you are actually speeding already above the still current limit. So that was ceiling speed monitoring, when you have a constant speed limit. The next thing is target speed monitoring. That is the thing with the brake curves. You have the current limit, and then you have a reduction in speed limit at this point, and you have to slow down. And the system is calculating brake curves. Again, you have different steps: the warning curve and the intervention curve, and above that again, imagine that the emergency brake intervention curve. And this is your actual speed. You're still below the limit, driving happily your way, and then you miss that there is a speed reduction incoming. And your cab display will at this point already show you the reduction in yellow, because you are already closer than 4 seconds to the speed changing point, and you have the shrinking yellow bar, and your needle is yellow, and you have this bar indicating the distance to the speed changing point. If you do not stay below the brake curve, that is indicated by the yellow bar, but go beyond the warning speed again, then you will have an orange part. The yellow thingy is still shrinking since you're getting closer to the speed changing point, and the orange part again shows you how far you are above the speed limit and how much you have to go until the train will react with an brake application. How much you have until the intervention speed. And this is a dynamic thing at this point, so the yellow one shrinks and the orange one shrinks according with it. If you, again, always with the orange one, beep beep, the alarm sound will be played. If you don't manage to get your speed below the intervention curve fast enough, the train again will react with an emergency brake application, or a penalty brake, let's say that, and it will again sound the alarm sound, the dee 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 sound. And if you are in target speed monitoring, at least this is what the DB directive says, you will get a penalty brake emergency brake intervention, popping the brake pipe completely, draining it completely at once, without a service brake intervention in between. Because this is obviously the more dangerous case where you are speeding, as compared to just going beyond the ceiling speed. So you will get an emergency brake intervention at once. Again, this indicator will be shown because it will always be shown when the system is taking control of the brake system. Your speed will be brought down, and as soon as you are below the curves, below the limit, there can actually 2 things happen. Either you are brought to a standstill, or the intervention will be released and you can take over control again and go on with the new ceiling speed. In the directive from the DB Netz AG, they tell you that on level 1 limited supervision you will end up with a standstill. On full supervision on level 2 you will be allowed to go on. The intervention will be released. Yeah, that is that. We have seen ceiling speed monitoring, target speed monitoring, 3-step process. The first thing is the yellow shrinking thingy telling you everything is okay. You have to comply with our brake curve, keep the speed, the hand of your speed clock below the shrinking right end of the yellow bar. If you are going over it, you will first get the orange and an alarm, and if you still go beyond the intervention speed, you will get a penalty brake application and the bar on your speed clock will turn red. The last thing for the presentation here in this context is what happens if you are not only reduced in your speed, let's say from 140 to 100 kilometers per hour, but you are ordered to stop. You are actually reaching the end of your movement authority. You have to stop in front of a red signal, for example, or a buffer block, or because this is your final destination, or whatever. How does that work? Let's just have another example. In the track, this is the track, you are allowed to go with a speed of 140, and here is a red signal. This is what we have already seen in action in the game. Since we have passed a yellow signal and the next one was red, we got this process already in the game. Let's draw our diagram. We have the 0 line here. At this point it starts and we have 140 before, so our speed line looks like this. Boom, it ends here with 0. We have to stop here. So we will have to aim for an actual speed diagram line of about this fashion. So we have to start slowing down and then come to a stop in some distance in front of the signal, but not too far away, not too sharp in front of it, just so that it makes sense. Yeah, the problem is, I have told you about this, we are getting our data from balises, and the balise that gives us the next movement authority will be behind the red signal. So if we stop in front of the signal and we are not allowed to pass the signal as soon as it switches to yellow or green, then we will never be allowed to move and catch our new movement authority from the balise behind the signal, because we can't go. This is why we need a system where we are actually allowed to pass the signal as soon as it has changed. In a world where we are not getting continuous information about the status of a signal, but only from the balises that we are passing. And this is this is done by a release speed thingy. We know that release speed concept already from the LZB. At the end of an LZB line you will be shown a release speed, and then you go through the LZB end procedure and you will be released to a certain speed, and then you continue out of LZB. Typically then you will have to run under PZB, but you will get a speed and thrown out of the supervision, out of the monitoring with a certain speed, and this speed you have to manage on your own, and quite alike under ETCS. So in Switzerland we have a release speed of 40, at least here in the game. In the German directive the release speed is typically much slower. It is 15 kilometers per hour, but this is something that can be defined for the track, for the route in question, and for the carrier in question. If we have a release speed of 40, we will have our ceiling speed monitoring along the 140, then the brake curve start, and then we will have our target speed monitoring along to the brake curve, until we reach the point where we need to be down to our 40, and after that we will have a static control to the ceiling speed that is equal to the release speed now. So the train will not control us further on a braking curve. The system on the train will not control us further, but it will only control us to this release speed from this point on. And why does it make sense? Because sometimes the positioning with the balises and the odometry is not so super exact that you can know for 1 meter or a couple of meters exactly that the train is standing in the correct position, and this is not so important in open track, but in a station area it is important, obviously, that the train is actually stopping at its stop marker and not anywhere else. And this exact positioning cannot be done with the necessary exactness with balises and odometry alone. So in this area here below the release speed, the system trusts the driver to bring the train in the exact position, not violating the release speed. And at the same time, as soon as the signal changes and the driver can go on, the system trusts the driver to not do this before the signal does not change. And as soon as the signal turns yellow or green and the driver starts again with the release speed, the train can pick up the next movement or authority from the next balise and go on. And then the release speed, or the speed target, obviously will jump up to the new ceiling speed that is applicable behind the signal. So this is the concept with the release speed. And what does it look like in our cab? Let's say we are running in full supervision here. We are controlled to the ceiling speed of 140. So we have our gray bar ending at 140 on my speed clock here, and this is where the brake curve begins. So at this point we have our shrinking yellow bar starting with the brake curve, and the special thing is, I hope you can see it on the stream, is that the left end of the yellow marker here is not ending at a specific point, and it is not ending at 0, but it is split. You see a gray part and you see a yellow part, and this is indicating that at the position where the full yellow block ends, this is your release speed. And at the same time you will get shown the release speed in a numeral that is in this position here. I just magnified it a bit so that you can see it properly in the game. This is actually displayed here too, but it is very small, obviously. Yeah, so your brake curve, just as we know it from the brakes that do not result in a release speed, the shrinking yellow bar, but at the point where the release speed is, it is split into two thinner bars. Before that, we will have the same as in the other context. 4 seconds before we hit the brake curve, we will get the, or are supposed to get, the yellow bar not shrinking. It shrinks not before we hit the brake curve, and we will get the DD, the attention sound. 10 seconds before, we typically can get the advanced warning, but we know that this has been deleted in the latest version of the SRS. And what happens as soon as we get to this point where the release speed is actually supposed to be reached? Then we will be released. The thick yellow bar has ended at this point, and the two thinner bars will remain. The thin yellow bar will still shrink, indicating you that you are getting closer to the point where the train thinks that you have to stop, and the gray bar indicating the release speed will not shrink. It will just be there and indicate the limit for your release speed. So these two thingies are there to tell you that you are in the release speed area and how far the train thinks that you still have to the point where you have to stop. And The important thing for me at this position here is that if you're actually going faster than this shrinking yellow bar allows, but are still within the limit of the release speed, the train will not intervene. It will not stop you with a penalty brake. It will not even show you the orange overspeed warning. At least this is what I get from the directives, because this is release speed. This is where the train is trusting the driver to comply with the signals and stop in the correct position. Otherwise, we would not actually need this release system if the train were to intervene at this point. And this is, oops, too far, actually called the release speed monitoring. So we have 3 different ways of monitoring: the ceiling speed monitoring, the target speed monitoring, and the release speed monitoring. Depending on what we are doing, if we are running on a constant, on a static line speed, we have the ceiling speed monitoring. In the brake curve we have the target speed monitoring, and if we are in a situation where we are trusted to operate the train within the release speed, then we have a release speed monitoring. So only if we were to accelerate above the release speed, then the train would intervene. And if at this point the driver were to run a red signal anyway, then the next balise would stop the train, because then the balise would tell him, hey, no movement authority here, and then you would get the penalty brake from the train stop feature with the red signals, or whatever system there is running, but not from the cab signaling control speed. Yeah, I hope that was not too confusing. I did my best to show you what the speed clock on your train should try to tell you in this context. Just for showing off a bit and to give you an idea how complicated this stuff is. This is the actual system requirements specification 3.6. So this is the actual document where all the requirements, you can see it here, for the ETCS system and how it is supposed to work are laid out. Subset 026-3 3.6.0 13 May 2016. You can see it is done by the ERA and UNISIC and the users group. You have the version history and everything, and I think it is about 8 or 9 chapters, and this document is only one chapter, chapter 3. And the part what interests us here, the supervision limits. That's what we have just discussed here. You find it here in epic detail. You have the emergency brake intervention speed EBI, the service brake intervention speed SBI, the warning speed W, the permitted speed P, and the indication for the early, the advanced brake warning. And then you have the release speed monitoring start location. And then you can see how it works. Ceiling speed supervision limits. That what we have just discussed. The warning above the permitted, and then the service brake intervention, and then the emergency brake intervention. All the variables are defined, and then it starts getting nice, because then you have all the formula and all the other stuff and the diagrams on how the target speed monitoring is supposed to work and how the brake curves are supposed to be calculated. And obviously I'm not showing you this to understand all that, and just to give you an idea how complex this stuff is. And these are 204 pages for chapter 3 alone. And why am I showing you this? To, well, actually give kudos to Rivet Games, because it is not easy to simulate all that complex stuff, and nobody can expect it to be without bugs. CD radar, what is it that you say? Let's put the presentation out of the way and let our stopping time run down. So it's as fully as PZB if a train receives a signal for a red signal, but it changes to green after a while, the train has to slow down. Yes. This is why the Euroloops exist. If you are actually approaching a signal where there is an Euroloop and you get at least for the 1 kilometer in front of the signal the continuous feed from the Euroloop, then the train knows that the signal has changed, and then it at least does not need to slow down any further. But if not, then the train has to stick to the release speed and pass the signal and get to the next balise, not violating the release speed, and then pick up the new limit again. So again, with all what we have heard, have a look on our display here. You can see we are still in a situation where we got a release speed indication. The release speed is still visible here slightly with the gray line, and the release speed is given here as 40 as a numeral. We see our full supervision icon, you see the level 1 icon here, and we can see that our bar indicating how far we can still go to the stopping point has already run down to 0, because we are already in our stopping position. We can also see that the signal has switched to green. The train does not know it yet, just as you said, because the next feed that the train is getting are those balises here. Before we are passing this balise, the train will not know that the signal has changed to green. Can we see the transmission module underneath our train? Probably not. No, I don't think that we can see the transmission module. So, we can go on. We are still in the release speed monitoring. We cannot go faster than 40 until we get new data from this balise here. And blop, we got our new movement authority, our new limit of 85. Now something funny happens. You see now our speed bar jumped to 145 for whatever reason. If you look at this here, you can see this 145 in this spike in our speed line. I don't know where this comes from. It is obviously not what is supposed to happen here. We are maybe passing for a short section of track speed, a line with a higher line speed, and now it reduced again to 85 in an instant, or 90 actually, because we are allowed to go faster then. Now you can see all of a sudden we get a signal speed reduction to 60. That does not translate here. Since the balises should also tell you a reduction in signal speed, I think you should actually get it on your display if it was implemented properly. But it is not. Also from the signaling standpoint, we got this green with the 6 commandment of a 60 reduction. without an announcement of a reduction to 60. I don't think that this should happen actually. If we're getting a speed reduction commandment on the signal, then we should get an announcement in front of it. But we did not. Okay. The next thing what will happen, since we are approaching Rothenburg Dorf, if you have watched the first stream about this DLC here, then you might remember that there is a weird speed changing point at Rothenburg Dorf station, where the speed limit just increases from 90 to 110 without any signal telling you so, without any sign telling you so. And on the cab signaling here you can see it quite nicely, where the limit just jumps to 110. We will have to stop at the station, so you will see that when we are actually slowing down for the stop. The next thing that you can see maybe on the speed clock is that the gray bar does not really hit the corresponding numbers on the speed clock, but it is a bit too short, and this will get worse with faster speeds. So the higher the speed limit, the more of a gap between the end of the gray bar and the actual marker on the speed clock. Now I'm slowing down early so that you can see the increase of speed limit from 90 to 110 blips. There it is. Without there being any signal or any sign. But the balises know it. Right? Just before our stopping position, the speed limit increased, and I have looked and looked and looked, but I have found no sign telling us so. Not an advanced sign, not an execution sign. But on the upside for Rivet, I think that this motorway here is actually represented really nicely. There is a lot of traffic going on. Especially at night, it looks beautiful. The scenery in this DLC, in most parts, is really good. It is well done. The road traffic looks much more realistic than in many other DLCs. At least in my humble opinion. Yeah, CD radar, but this is where it becomes quite obvious that non-continuous train control has its flaws. Because every control can just be as good as the data that the train has. And on level 2 you would not have this problem, because then you have a continuous feed from the radio. And you can throw away your expensive Euroloops again. This is why nobody is actually using the level 1 full supervision. I guess. Around Rothenburg there will be the increase to 120, but this time it will be signaled. Let's go beyond the speed limit a bit and see how first it turns yellow in the implementation here, then it turns orange. You hear the alarms, sound, and as soon as I slow down, the system is happy, because the stop at the station is not signaled on the speed on the cab signaling system, obviously, because it only indicates the track speed limits and signal speed limits. So you have seen that the hand and the bar turned yellow before it turned orange. According to the directives that I read, it should go directly from gray to orange. And the yellow color is only for brake curves. But again, maybe this is a specific of this current, this specific version of the system that Rivet implemented. So I can't actually say that this is a bug. Maybe this is just an old version, but on the newest version it should go directly from gray to orange. On the real thing, by the way, you're getting even more indicators for initiating your braking process. You can see this square here in the corner and this field on the display. On the real thing you will see a growing square in the square on the top left that starts turning from yellow to orange and then red, and at the same time some indicator here that is, well, getting bigger and more obtrusive the more urgent the train thinks that you should apply brakes finally. But this is not implemented in the game. On our way to Sempach-Neuenkirch, maybe we should try to get a penalty brake and see what the game actually does to us. If it applies, let's see, let's have the brake cylinder and the brake pipe indicate. No, this is the main reservoir, not the brake pipe, but anyway, let's see what we can see on our manometers. So we can't really see if it is draining the brake pipe completely or just applying a regular service brake application. Yes, cheese. Alarm, yellow, warning. Yes, and here is the emergency brake. We're getting back to speed and it is getting us to a standstill. So our train is not fussing with service brake application and releasing it. It is popping the brake pipe, draining it to 0 bar and getting us to a complete standstill. And then it releases automatically. Brake cylinders drain, and I have the combined lever still on power, so it just goes on again. Again, we have seen this on level 0. I don't know if this is what the system should do after a complete standstill, just recover on its own. Again, in case the driver is incapacitated, the train would just go through this cycle until something stops the train, until it gets derailed most probably. So probably the system should wait for the driver to acknowledge something before it just recovers and goes on with its journey. Also here the road traffic, I think the road traffic is really done nicely here on this DLC. I think Rivet is not getting enough appreciation for its or their work on the scenery for this DLC. So I'm trying to stress that. So obviously we are a bit late because of our penalty brake. Okay. Here you can see how the gap between the end of the gray bar and the actual marker on the speed clock is getting bigger and bigger. It is already here more at 117 than at 120. Now the track limit increases to 125. The indicator is at 122. But as far as I have seen, it is actually controlling you to 125 at this point. Now we should be getting close to the 160 limit increase. And again, the indicator on the speed clock will jump to the 160 as soon as we hit the balises. Here is the advanced, here's the sign, here are the balises, and it jumped to 160. Now the train has run its length, we can actually accelerate to the 160. I mustn't forget that we are running an S-Bahn service and that I have to stop in Nottwil and Oberkirch. Nice thing is that we do not have a SIFA or something like this, so we can go for some nice externals in between. What is a bit annoying is that the zoom always gets lost when you switch back from the external cameras to the inside cameras. Oh, and as I said, I forgot to apply the brakes. And we are running past the station. What is obviously a problem, since we passed the signal, so I cannot really set the train back. Yeah, please don't judge me for that stop. My focus was obviously on something else. At least part of the train, one pair of doors, is still at the platform. Stop in Oberkirch, and then we can have another look on the yellow brake curve representation. Train from the other direction. Yeah, on the way back, yeah, well, we will run a fast service back, I think. Then I will explain it then. Here you can actually see how the track is going into a descent in front of the station. It's rare that you can see it. Yeah, thank you for the reminder. I was already on my service back, but this time I just noticed it in time. Yeah, well, I won't win a trophy for the for the stops today. but maybe for the shots. Again here scenery. I love that you can hear the engine of this bus idling, and that people are actually spawning behind this bus when they are getting to the platform. At least we get full points for being on time. So, but now again the brake curve for the stop at Sursee. This is why I took a slow train to Sursee, because the fast train goes to a different platform in Sursee, and there the end procedure does not work. The fast trains will be sent to their platform up to a red signal with full movement authority of 60. So, now we are in the yellow curve. It is already shrinking. You can see that we get signaled a 40 release speed. And you can see the bar that is indicating the distance to our stopping point. But this is actually a point where I can understand your friend, that you're looking more on the speed clock than on the track here. Yellow signal. We are already in the release speed, and now I will just let our speed go beyond the shrinking yellow speed bar. And I think that the game is giving us here an overspeed warning. Although we should not get an overspeed warning here, because we are in release speed. Ended with an emergency brake. At the red signal. Well, I think this is implemented properly, the ending procedure here. On the other service back, yeah, stopping, except for the emergency brake application at the end, but I sometimes get into the emergency brake application if I don't move my finger from the key. What did I want to do? I want to start a service that starts at 15:35 and is the fast service back with not so many stops. And we can see some peculiarities in the programming for the track. So, doors, master key, reverser. And since we are a fast service, Basel RABe. Again, starting, we are in staff responsible mode until we get to the first balise. You can see that we are running up to a yellow signal with a 10 numeral telling us that there is a limit to 100 ahead. At the moment we are at a limit to 60, but since we are in staff responsible mode, we must not go faster than 40. And this is actually implemented well, because if we try to go beyond the 40, just showing, we will get an emergency brake just because we are going beyond the 40, although there is no indicator. Warning. Now we actually did not make it because we got the balise in time, so we did not get a penalty brake. Now we get indicated 100 from the signals. What is not correct at all. We should get a 60 because we are still in the 60 because the length of our train, or a 140 because we are in on a 140 track with the tip of our train, and the signal speed of 100 is just announced and not commenced yet. So you can see we have a yellow needle, although we are within the gray bar. Now we have passed the 100 limit and the needle turned back to light gray. The 100 limit is because we have to run across this switch here. As soon as the tip of the train is out of the switch, the indicator goes back to 160. Obviously we have to run the full length, but this is not the problem. I delayed the acceleration so that we don't go beyond the 100 too fast. And we can accelerate to the 160 line speed. Next stop is in Sempach-Neuenkirch. So we can just watch what the cab signaling is showing us here. On the way from Luzern to Sursee, the limit typically increased, and so the other way around, the limit typically decreases. Line speed coasting, passing Nottwil. And I think we will get a white advanced brake warning for the 125 reduction that is incoming after the next bend to the right. That tells us that we are at least not in SRS 3.6. Now you can see it. The white part. And you can see it is shrinking actually. What I think it should not do, it should turn yellow and shrink then. But it is staying gray and is shrinking. Now for a very short while then the reduction to 120 while we are approaching Sempach-Neuenkirch. Aufmerksamkeitszone, attention zone. You can see the very short reduction. Forcing me to brake ecstatically since I was late again. On the right side, by the way, of the display, where you see those lines and the distance is 2000, 1600 and 0. On the real thing you would get information about incoming track points of interest, like speed changing points or points where you have to lower your pantograph and all that stuff. But this is not implemented in the game. Here on this side. So the 0 line is more or less your train, and then everything like in a computer game drops like in a Tetris game from the top to the bottom, so that you can see what is incoming. You even got the representation of the length of your train underneath the 0, so that you can see when the end of your train has passed it. Nebula. Yeah, exactly. What I have not seen implemented in the game are ETCS shunting signals. What is a bit sad, because they are blue and they have a very, very nice blue tone or shade or tone of color. And there is a separate mode of operation for shunting, where the system more or less monitors a certain ceiling speed all the time. So, we are approaching the bend with the big G's, what typically marks that we are getting closer to Rothenburg. First, the big containers on the right side, and then the big G's on the left side, and here we are at the summit of the hill. Always needs a bit brakes, big G's, and the ideal marked. Here we always tend to overspeed a bit, since we are going in the decline, in the descent. It's actually a bit sorry or sad that we don't use the sidings here in this area. Could have some nice shunting missions here. The reduction from 120 to 110 is announced. And again, the white curve is shrinking. It is not yellow, the white curve is shrinking. And again, I'm not paying enough attention on my stopping. On the next lap from here to Rothenburg Dorf, we will get a penalty brake because there is obviously a flaw in the data that we are getting from the balises. We will see that there is a reduction from 110 to 90, but there is a certain... Oh no, let's drive it differently. We will not get a penalty brake because we will slow down fast enough, but we can see it on the gray bar how the limit just drops from 110 to 90 without any brake curve and much too early. We got the penalty brake last time when we were playing level 0, and I said we will watch how this looks on the cab signaling on level 1. And this is what we are doing now. We are actually in a 110 limit at the moment currently. And I will not go faster than 80, say. And just watch the gray bar and what it does. And at the same time the signals that we are getting. So far, so good. 110, no discussion about it. And we're passing the signal, and then you can see on the left side the advanced sign for the 90. Here you can see the advanced sign for the 90 incoming, and bloops, even before we get to the sign, the speed limit without any brake curve drops to 90, then it climbs back to 110 for whatever reason. And this is why we're getting penalty brakes in level 0 here, because the level, the speed limit just drops to the 90 out of nowhere, and then we are obviously above the intervention speed and we get a penalty brake. Now it dropped back to the 90, and now we're getting a brake curve because obviously there is a signal up ahead that requires a stop. You can see release speed 40. You might think, oh no, it is one of those services where the next signal is red and we can finish it because it is perma-red. But no, it is a different one. I picked this service deliberately for this yellow in front of Emmenbrücke. Slowing us down below the release speed. Yeah, and the signal already turned to yellow and now it turned to green. The train does not know because it did not get any data from the balises, but we as a driver can take responsibility, and this is the point where we should not get the warning. We should be allowed to go back to the 40, pass the signal, get the new movement authority that we did not get. Now you can see the system is totally off the rails. It is just indicating an orange bar from 0 to whatever, 7 while indicating 34. It is not even displaying any release speed, but we are still in full supervision. Will it stop us if we go beyond the 40? Yes, it will. You can see it was still monitoring our release speed even though it was not displayed anymore. Well, now we are getting an overspeed warning starting with a speed of 4, and now we are in the point, you can see, where the limit of 80 is inbleeding. We've discussed this in the last video, and it is picked up as a 90 limit. Obviously we are already out of it, but the speed line says we are still in the 80. Let's see what we get from the next balise. Well, now we should get the incoming reduction to 85. No, we are getting a new signal that requires us to stop. So the reduction to 85 does not get shown. Here is the yellow signal. It turned to green. Now we got the new data from the balises. This is why the yellow curve went away. That is correct, I think. The reduced limit of 85 is shown. And we have to stop at Emmenbrücke station. So in this last part from Rothenburg to Emmenbrücke, there was, in my opinion, a lot of confusion going on with the cab signaling. Especially the orange bar starting at 0. This can't be what it is supposed to be. Another thing obviously is that the real system sometimes has bugs in its implementation. So it is a philosophical question. If you are programming a simulator, should you actually program that bug into your simulated system, or should you program the system as it is supposed to be, not as it actually is? Always given that you are actually in a position where you can simulate it that exactly. Last lap. I will not do what I did last time. We will again pass the dark signals. That should require an emergency brake application at the dark main signal, but I will just ignore it for now. Let's say we have a written order that we are not supposed to look at the dark signal. Even with a written order we would have to pass it with 40, I guess, but still. let's assume we are in a position to just ignore this dark distance signal here. The reduction to 60 here for the switch is signaled correctly in my opinion on the cap signaling here. We will get an advanced warning for the 60. Now we're passing the repeater. Now we're getting in white the announcement. Probably should get a yellow braking curve. We're not getting a yellow braking curve. As soon as it starts, we're getting closer to it. Now we're passing the dark main signal here. Normally I should yank in the emergency brakes. Well, so much for that. It was not signaled properly. It just dropped to 60 without any yellow braking curve. We just got the advanced warning about it, and then it dropped, and the penalty brake application. So unfortunately no yellow shrinking curve, but only the white shrinking curve maybe. The train does not. Yeah, the train does not want to recover on its own now. Maybe I did not have any power on. What a mess, you say? Well, to be fair, it is a bit of a mess. But this is why I showed the SRS, or at least one section of the SRS, to, well, show my appreciation for Rivet that they actually tried to implement it. And only if someone is bold enough to try it, you can get closer and closer to the real thing. Well, I think Dovetail games should do things like this on their own with their budget, not leave it to Rivet Games, or like with the Trax 3, the Baureihe 187, leave it to Skyhook to mess it up and get all the blame. The more complex systems. Now I'm slowing down below the 60 because you see we're getting closer to Luzern station, and we should get a reduction to 40, but you could see what happened. Yeah, it started with a brake curve of 80, jumping to 60. So if you're going 70 at this point, you get the next penalty brake, and then the white thingy shrinking again. Well, I will not challenge this opinion, CD Radar, that you say this is unplayable. If you know about the bugs, then it is playable in my opinion. But to be fair, I'm not gonna lie, it is a first attempt and it needs a lot of looking into it. The next thing is we are approaching a buffer block, and our system is still giving us a movement authority of 40. There is no release speed or whatever. If we just go by the cap signaling, we are allowed to pass this buffer block with 40. Good thing is that we still got our eyes, and we are not trusting on our cap signaling and stopping our train anyway, and not running through the buffer block with 40. Yeah. Well, Yeah, well, okay. I don't want to make fun of what I did of the ETCS, but this is what I am able to tell you at the moment about how it is supposed to be, in my opinion, and how it is actually implemented. To summarize this a bit, I think Rivet Games should totally be appreciated for trying it, for implementing it, but also encouraged to work on it a bit more, because at the moment there are a bunch of issues. That was the service, and I hope I was able to demonstrate how the cap signaling on ETCS in general is supposed to work. Obviously there is much more to it, like level changes and other things, but I won't go into that. And this was more or less the simple driving and braking procedures and the release speed procedure here. So it is a step into the right direction, and I always have the feeling that Dovetail Games and the third-party developers are not putting enough stress on implementing signaling and safety system, but well, listen too much to the people on the forums that complain about things like sounds and other stuff. But well, that is the problem. If you have a really complex game like this one, where you want to do serious simulation in a sandbox style world, everyone gets obsessed with something else. One with the signaling, one with the safety systems, the other one with the correct placement of the stickers on the liveries, the third one with the behavior of the passengers, the fourth one with the sounds, the fifth one is insulted that the fish and chips booth next to his house is not represented in in the representation of a certain station. So I think it is really hard to achieve something in a context as complex as this, and the more they are implementing, the more complex it gets. The more modern system they are actually to implement, the more complicated everything gets. Like, it is one thing to implement a diesel electric locomotive from the 1960s and have it run on the signaling that you have on sandpatch grade, and it is a totally different thing to build and simulate a modern Trax 3 or Vectron locomotive and have it run on ETCS, or even the access implementation and the cap signaling in the northeast corridor. Well, steam trains, as soon as I have learned how to drive a Steve engine without the HUD, then we can have steam trains on the stream. For now, thank you very much for watching. Thank you for moderating the stream, AJ. Thank you very much for your comments, CD Radar, and yeah, we will see what we do next time. This was the last stream in a row about ETCS, and yeah, I am done with this topic for the moment. Next time we will do something completely else, something completely different. Thank you very much. Have a nice time, and see you around.